Hi, in today's video we will demonstrate how to create a very basic TCP IPv4 load balancer using Flomesh Network Load Balancer FnLB. FnLB is a hyperscale software load balancer for cloud native workloads. In today's video we will demonstrate how to install FnLB and how to configure it using the CLI that comes with it. For demonstration purposes, we'll be deploying a demo setup for the topology that will look like this. So we have 5 different endpoints. One is the FnLB load balancer itself, and we'll have a client. We call it L3H1 here in this diagram, and 3 different endpoints: EP1, EP2, and EP3. The client will be communicating with the endpoints via the load balancer FnLB here. And just to make the demo more interesting, we have configured the subnets, different subnets. So the client is listening on subnet 10.10.10.1. Load balancer is listening on IP 20.20.21. Similarly, endpoints are listening on 31, 32, and 33 different ranges there. So we'll start with installing a FnLB via the Docker, and then we will install the 4 different endpoints, including the client and 3 endpoints. And then we will set up the communication network between all of them because they're listening on a different subnets or different networks. So let's get started. Let's see. We'll be using the Docker for today's demo. So we don't have any of the Docker instance running. So let's start with installing our FnLB first. So here what I'm doing, I just copied my shell script here that's going to create a FnLB instance and doing the configuration of the network. Take a look at that. Okay, so we have now, just to highlight the path here, this is the one. Flomesh FSM XLB is the image that it contains the FnLB software itself. And to run this image, we need to have the admin privileges. That's why it is the privileged one. And we need to have the capacity added by the system admin. And these steps we are adding or setting the networks, especially the ARP1. So now we have this in place. Let's add the remaining 4 endpoints, what you see here. Similarly, we'll just use a simple bash script, bash, to create 4 of them. Let me clear my screen. So now here you see we are just looping through that one. So we are going to create L3H1, L3EP1, L3EP2, and L3EP3. And we are going to perform the same configuration we did for our FnLB. Okay, it's done. We can double check. Right, so we have all these images up and running. To make things more interesting, FnLB comes with this support for creating a mirroring. In that way, actually, you can mirror the traffic so that you can use it to analyze. And for this demo purpose, we'll be just installing a Wireshark so that actually we can view the traffic that is flowing through the FnLB. So let's install a Wireshark container. Okay, so we have that one. Now we are done with installing all these endpoints as well as our FnLB. And as you can see, actually we are running the 5 different Docker instances there, Docker containers. but they are still isolated. Actually, they are unable to access each other in this sense. So now if you take a look at our this diagram, we need to set up the communication from host to load balancer, similarly load balance to different endpoints, so that load balancer is able to access all of these endpoints, and similarly endpoints to the load balancer, and load balancer back to the client. So let's configure it. Let's first create a link between them. Okay, the linkage is done. Now we need to configure the flow from host to LB, and similarly endpoint to the LB, and so on and so forth. So again, I'll be just using the script I've already prepared. So here you can see we are creating a link between L3H1 to the LB, EP1, EP2, and EP3, and backwards LB to the different endpoints. Right. So let's add our FnLB or FnLB IP to them, to these endpoints we created. And now we need to create a kind of mirror link which we will be using in our Wireshark to capture the traffic. Let's create that one. Okay, now we have things done. I mean, the relationship or the link between the different endpoints is being created, and we should be able to see that one. So you can see actually we have different networks, already namespaces created, and we have all those links set up. So just to make sure actually our FnLB CLI, we have access to that one. So what we can do is we can run docker exec LLB1 is the name of the image that is running the FnLB, and we need to access our CLI. CLI name is FSM-XLBC. Oh. So okay, so we can access that one. This our CLI FSM-XLBC is what you see. What we use for kubectl is to the Kubernetes. So this command line provides a similar functionality but for FnLB, and we'll be using this CLI to configure our FnLB. Similarly, we need to make sure we can access, or we see that just to make sure actually networks, internets, and individuals Docker instances are the containers running is up and running. So let's first check L3EP1, and we can see, okay, so we can see this is it's 0 in L3EP1, and this is the IP address for that one. Similarly, we can do the same for the others one. Right, we are good. Now just take a look at the route information on our LB side. Okay, so you can see our routes. So the routes are properly set up, and just do a double verification that we are able to access the endpoints. So we can just do a ping. For example, see, you just write from the LB, our FnLB, we just try to ping our 31.31.31.1, and as you can see, this is the endpoint 1. So see if we are able to ping that one. Right, so we are able to ping, so it's mean the network is well and good between these endpoints. Now we need to create a load balancer, because that's the main intention. This was just the setup of the the environment, what will look like here. But the main thing is actually we need to create a load balancer. So we can double check. This is our command line, right? The CLI. You can see if we already have one. We don't have any load balancer created yet. So first we need to create a load balancer. And for the time being, what we are going to do, we are just going to give a one endpoint to our load balancer. So you can see actually create a load balancer, and this is the IP of the load balancer, and this is the mapping. 2020 is the port of the load, the node which load balancer is running, and 8080 is the target port. So let's again just see if we are able to see that one. Okay, so we can see now we have this LB created, but this is a single endpoint. Now let's configure our mirroring as well, similarly what we did for the networks, because we're using this mirror from our Wireshark to access the traffic. Create mirror 1. That is actually from FnLB or LLB1 to and forth between endpoint 1. And similarly, we can create a 1 for EP2. So this mirror is going to capture the traffic flowing from network load balancer to the endpoint 1 and endpoint 2. And we can create similarly for 3, 4 and others, if you have any. So just to double check if our mirrors are created properly in FnLB, we can run the command CLI and get mirror. Okay, so it shows actually the mirrors are created properly. Now our endpoints are running, but we don't have any service running on them that's listening, and because in our NLB rule we created that we'll be actually forwarding any traffic coming to 2020 to 8080 of the endpoint. So let's just use the socket, and so that we can just create a very simple service on all 3 endpoints. So I just copied my here. What I'm doing here is actually creating a socket server listener 8080, and that is just going to return server 1, server 2 and server 3 respectively on those individual endpoints. Okay, so now we have created that one. So let's just double check. So I just write a simple script here, so we can use this script to verify if we are able to access our host 1, the client 1. So here you can see server 1, server 2, server 3 are up, and here you see actually we executed this command from our host. So this means actually host if you go back to our diagram, so host is able to access endpoint 1, 2 and 3. That is what we are doing here. So now services are up and running. Now we need to check our load balancer. So let's run 4 times a request, send a request to our host 1 and see what we receive. So here we are iterating 4 times, and we are just using the socket invoking a request on 2020. That is the network load balancer port, right? And the IP. So in that way, we just want to see what we receive. Here we go. So now we are actually receiving 4 times server 1. Why is that one? You remember we have set up configure our load balancer with only a single endpoint. And this 3031 in our diagram is the server 1. And that's what we are seeing here. So now let's reconfigure our load balancer with all 3 different endpoints and see how the response will be returned. So the same command, create load balancer, the same similar IP, but endpoints now it contains all 3 endpoints, 31, 32 and 33. Those are the IPs of our 3 different endpoints. Okay, so we receive a 200 success. That's good. If we just run again, get endpoint, now we have 3.1. And if we run our that request 4 times now, we should be able to see a response from all 3 endpoints in a round robin fashion. So here you can see we are receiving the response from 3 different endpoints, and the 4th request goes back to the server 1. That shows actually the round robin is the default mode, because when we created our load balancer, we didn't provide any algorithm, how it's going to do that one. The FnLB supports multiples of them. Round robin is the default, and it also have the weight round robins and so on and so forth. When in round robin fashion, this weight 1 doesn't count because this is a simple round robin. But if you change our load balancer to the weighted round robins, in that way the weight will count. Okay, now as we created a Wireshark, right, so we should be able to access our Wireshark. Here we go. So this is the Wireshark running on our server, which I'm performing this demo, and this is the one, right, our mirror. So we need to capture the traffic here and this one, and just hit this. Now because we are performing it later, then if we go back and run the same command again, so you should be able to see the data coming from through. So in that way, actually you can see that mirroring is working perfectly fine, and we are able to diagnose. In that way, actually, you might be able to capture your traffic or forward your traffic to some of your IDS or IDP tools or some other purposes there. So that is the purpose of the mirroring. That's all for the demo, and once we are done with that one, we can just perform the cleanup, so that or you can play around in that way. But once we are done with that one, you can perform the cleanup. So let's all just see how to perform the cleanup. So what I'm going to do, because now if you see that our services are up and running, and we have all those things created, networks access created. So let's just create that one. First we are going to stop that socket services on that one, and then we're just going to remove the networks namespaces. Again, I'm using the same script, and now finally we can just remove our container. This is for demo purposes only. Definitely in your environment, production environment, you don't need to perform these steps to perform the cleanup. This was a very basic. As you can see, actually we just didn't configure anything. We only configured the endpoints, and we used the default settings of the FnLB, and we were able to load balance our traffic or the request among 3 different endpoints which we created. That's all from my side. If you have any questions, feel free to reach us. Thank you for watching.